Hello, Algebra 2 and or Pre-Calc students. This is about what we're looking at polynomial graphs here. This is one of the things we look at when we're looking at polynomial graphs, really, and other kinds of graphs, is end behavior. This is just something we tend to want to know about when we're analyzing the graph of whatever function. Okay, and so I want to talk to you about end behavior, but first I want to talk to you about the thing people tend to get most confused about between end behavior and this, and that is intervals of increase and decrease. Now at this point in my Algebra 2 class, we talked about intervals of increase and decrease when we were talking about quadratics, okay, so parabolas. And we said, hey, we have a turning point. At this point, the parabola turns around. And up to that point, it's increasing. We always read it from left to right, so it's like somebody's walking across the graph from left to right. He's going uphill on this side, sliding downhill, decreasing. Okay, so that's interval of increase and decrease. It's basically interval of increase and decrease is in the middle of the graph. It's talking about what happens on either side of turning points. End behavior is completely the opposite of that, really. Well, I don't know if you would call it the opposite, but basically it has nothing to do with what's going on at a turning point or what's going on in the middle of the graph. End behavior says, I don't care about any of that. I want to know which ways the ends point. That's it. That's all I care about. It could do a loop-to-loop in the middle here, and I could care less. I just care about what happens on the ends. That's what end behavior is. So for instance, let's say we have this graph. Definitely no longer a quadratic. Okay, it looks like it's got 1, 2, 3, 4 turns. So there'd be a lot of different places where it's increasing and then decreasing and increasing and decreasing, all of that. But again, if all we're talking about is end behavior, or when we are talking about end behavior, all we care about is, hey, it seems to point down on the left and up on the right. And wouldn't life be grand if we could just state it that simply? Hey, this points down on the left and up on the right. And really, that's all end behavior is. It's pointing down on the left, up on the right. This one was pointing down on the left and down on the right. That's really all end behavior is. But two things that we're going to make it more complicated, because that's what we like to do in math, right? One is we're going to say it in a more mathy way. We're going to say it mathematically instead of saying down on the left. Another thing is we're going to talk about how can I tell, without looking at the graph, what to expect in this respect. In other words, if I'm looking at, for instance, this polynomial, how do I know just from looking at the equation what's going to happen? Is it going to point down on the left, up on the right, up on the left, down on the right? What's going to happen? Okay, so if all we're interested in is what happens on the ends, basically you've got two options. On the left side of your graph, it's either going to point up or down. You got two options on the left, and you also have two options on the right. On the right side, it's either going to point up or it's going to point down. So there's a limited number of combinations. All right, and it turns out that you can see that limited number of possibilities if you analyze the graphs of lines and parabolas. Okay, in other words, let's look at a linear equation. Assuming it's not horizontal or vertical, a linear equation could go like this, or it could go like this. Basically, either the left end is down and the right end is up, or the left end is up and the right end is down. Those are my options. Left pointing down, right pointing up, or it could be left pointing up and right, down on the right. Those are the two possibilities when I have a line, assuming it's not horizontal or vertical. Okay? Then the other option is they could both point the same way. So if I have a parabola that opens up, they point up on both the left and the right. Up on the left, up on the right. If I have a parabola that points down, opens down, then it's down on the left and down on the right. Again, I don't care what's happening in here. Could care less. Couldn't care less, rather. Okay? But I do need to know if it looks basically like this in terms of the ends, or this in terms of the ends, or both up or both down. So those are your only four options. If they point in opposite directions, either it's left on the down on the left and up on the right, or it's up on the left and down on the right. If they point in the same direction, either they both point up or they both point down. So we've only got four cases that we really need to know about. And here's why, one of the reasons I went ahead and talked about these, which are lines, and these, which are parabolas, is that we can model everything else in terms of those. Okay, an equation of a line. Here's just a random equation of a line that is not horizontal or vertical. Okay, y equals 3x plus 2. What is the degree of that equation? Okay, degree, remember, is the biggest exponent. So the degree of this equation is 1. Which one of these would this be more likely to be? Is this y equals 3x plus 2, or is this y equals 3x plus 2, assuming that one of them is? I would guess that this one is, because it has a positive slope. This one might be something like y equals negative 5x plus 1. That seems reasonable. It really, I'm not trying to be accurate here, just pointing out that I know that this one has a positive slope and this one has a negative slope. I also know that they both have a degree of 1 because that's what a line has. Well, it turns out that anything that has an odd degree, 1 is an odd number. Anything that has an odd degree, whether it's 1 or 3 or 5 or 7, it could be anything that's odd. Any polynomial that has an odd degree is going to act like a line, where the two ends point in different directions. So just like a line, it's either going to be down on the left and up on the right, or up on the left and down on the right. Just like a line, the thing that makes the difference is the sign right behind the equal sign, the sign of the leading coefficient. If your leading coefficient is a positive number, it's down on the left, up on the right. If your leading coefficient is a negative number, it's up on the left, down on the right. Okay? Then just like a parabola, which is the easiest type of function where both ends point the same way, parabola, this could be like y equals x squared. Okay? It has a degree of 2. Well, again, it turns out that any degree that is, well, let's write this over here. Let's say it's x squared plus 5. Any degree that is even is going to act like a parabola, which also has an even degree, meaning that both ends are going to point up or both ends are going to point down. All right? So for instance, here both ends point up because the leading coefficient, in this case, is just a 1. It's a positive 1. It opens up. This one is more like maybe this. Still has the squared because it's a parabola, even degree. Leading coefficient is negative, so it opens down. So if you have an even degree, it's either both up or both down, depending on the sign of the leading coefficient, the number in front of your first term there, assuming it's written in standard form. So positive means they're both up, negative means they're both down. Okay, so let's make a little chart of this. All right. So far we have, if we have, let's see, let's say even degree, odd degree. If the leading coefficient is positive, okay, positive leading coefficient, even is like a parabola with a positive leading coefficient. They're both going to open up. All right, if the leading coefficient is negative, they're both going to open down, both ends. If we have an odd degree, this is the degree. The degree is even, the degree is odd. If we have an odd degree and the leading coefficient is positive. Odd degree, we said, just like a line, they'll point in different directions. Leading coefficient is positive, it's left, down, up, right. So, like this. If the leading coefficient is negative, it's going the other way, just like a line with a negative slope. Okay? So again, that's all you're really saying with end behavior, but again, we don't get to say it that simply. We actually have to say it in a mathy way. So here's the mathy way. Think about the coordinate plane. Notice that all of these, I was using words like up and down and left and right. Okay? So up and down and left and right is going to go away, and we're going to say it in a more mathematical way. So left and right. Notice we're always talking about left and right, whether they both point up or they both point down or one goes which way. We always say something happens on the left, something happens on the right. So when we're talking about end behavior, our two ends, we talk about the end on the left and the end on the right every time. So the way we describe left on a graph is we say, as x is approaching negative infinity. So to say x is approaching negative infinity says over here on the left. So left, we're going to say x is approaching negative infinity. And to say right, we're going to say x is approaching positive infinity. That's how we're going to describe the right-hand side. So every time we're talking end behavior, we're going to say both of those things. And we usually say as x approaches negative infinity and as x approaches positive infinity. So as x approaches negative infinity means as I move this direction, here's what's happening. As x approaches positive infinity says as I move to the right, here's what's happening. Now the function is kind of like our y. This is like y. The f of x is like our y. So the function value is either going up or down like y. Okay, that's the up and down part. Okay, all these words, left, right, up, down, those are the words. So up, we're going to say f of x approaches positive infinity to mean up. And down, we're going to say f of x is approaching negative infinity. And you can't see it. There we go. So we're always going to say left and we're always going to say right. And then we're going to tell whether it's pointing up or down according to what it's actually doing. So I'm going to rewrite this chart. My leading coefficient is positive. Leading coefficient is negative. Even degree, odd degree. So again, and you might want to think about it this way, even degree means we think about a parabola. Odd degree means we think about a line. So if I have a positive leading coefficient parabola, this one's going to look like this. The two ends are going to both point up. Negative, even degree, they're both pointing down. Positive odd degree is like a positive slope line. Negative odd degree is like a negative slope line. So here's what I'm going to say. I have to describe what happens on the left and I have to describe what happens on the right. So I'm going to say, as x approaches negative infinity, which is just a way of saying on the left, the y values are pointing which way, up or down? Up. That's positive infinity. As x approaches positive infinity, which means on the right, again, both sides point up. So the y value is approaching positive infinity. So on this one, on the left, it points up. On the right, it points up, is what that's saying. Let's do it here. On the left, as x approaches negative infinity, it points down. So f of x approaches negative infinity. As x approaches positive, infinity, the function again points down. It points down on both sides. So this says, on the left, it points down. On the right, it points down. Sometimes, by the way, this will be said opposite way. In other words, it'll say f of x approaches infinity as x approaches negative infinity. You could turn that around, and that would be fine. Just flip-flop the order. So here we go. As x approaches, so notice I'm always going to say, I can go ahead and assume I will always say these two things, because one of them tells me on the left and one of them says on the right. So I'm going to tell you what's going to happen on both sides, regardless of what's happening. So I'm going to say on the left and I'm going to say on the right. This is for a polynomial graph. When we get into more complicated graphs, it can do weird things in the middle. It doesn't have to be on the left. It doesn't have to be on the right. But for polynomials, which are continuous, they keep going to the ends, basically, till they go off the graph. Yeah, we've got left and right. That's the only two sides where something could happen. Okay, so this is like a line. On the left, it points down. So f of x approaches negative infinity. On the right, it points up, so f of x approaches positive infinity. This one's the opposite. On the left, f of x approaches positive infinity. It's pointing up on the left. On the right, f of x approaches negative infinity. Okay, so for instance, so this is basically, these are your four answers. Anytime you're asked what is the end behavior of this polynomial function, you're either going to say this, 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 or this. That's it. Those are the only four options. So going back to our little polynomial we had right here, it has a degree of 5. That's odd. So here I'm basically going to treat it like a line, meaning the two ends are going to go in opposite directions. It's either down on the left and up on the right, or up on the left and down on the right. The fact that this is positive tells me it's the first one. It's like a line with a positive slope. And for everything that's like a line with a positive slope, odd degree, leading coefficient's positive, this is what I say. So that would be my answer. Everything that's in this box would be my answer if I was asked for the end behavior of this polynomial. All right, let's look for another one. Let's say my polynomial is it really doesn't matter what happens after the first term, right? Because all we want to know about is the degree of the whole polynomial. This is all assuming it's written in standard form, which means the biggest exponent is first. And we want to know the sign of the leading coefficient. So this is even. So that means it's going to be like a parabola. Both ends are going to point up, or both ends are going to point down. This says down. They're both going to point down because the leading coefficient is negative. So my end behavior for this guy would be everything that's in this box. I would say as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches negative infinity. This says on the left, it points down. On the right, it points down. So I know that my graph is going to look like this, even if I don't know what happens in the middle. In the middle, it may do this. Okay, degree of 4 is not going to do that. It may do this. It can't have quite that many turns, so skip this term. But I don't know what it's going to do. I don't care. If I'm being asked about end behavior, I don't care what happens in the middle. I just care about which direction the arrows point. And it's not a question of increasing or decreasing. We're not talking about increasing or decreasing. We're not talking about that. We're not going across the graph from left to right and this guy's going on top and going up and down. None of that. It's just which way do the arrows point, and that is all I care about. The end.